some of the technologies that we've been testing on the ground. I don't do research myself. I'm a bit blonde for that, but we did ask quite a lot of research institutions. So any technical questions, please refer to Musa. That's why he's not here. Okay, so just some information, and the typing or the reading will be very limited, promise. There's a lot of cool videos coming up. But the aim of my program, the Advanced Orbiter Knowledge Program, is to actually try to find information ahead of the face. Where's the reef? What's the metal content? And that's what's impeding extraction. So I focus quite a lot of the impeding extraction, especially geological structures and features. And we currently have three main focus areas. We're doing quite a lot of work with what we call the smart drill, technologies ahead of the face and as well on the face. And then we've moved away from, or we used to have a specified project data or statistical analysis, students not here. And what we've decided to do is actually to make it part of all three areas rather than to have it on its own. So then when I heard geophysics and engineering, my first thought was, I'm not sure how it would work, but then I started looking at what are we currently doing where the two comes interact with each other. And I've got some very, very cool examples that I'll take you through. So a lot of people will say, why is there a challenge to actually take technologies underground? What's the issue? A person hears about machine learning, AI, robots, computers, radars, and all kinds of fancy stuff, drones. But I think the main challenge that we have is industry's reluctance to change. You're sitting with an older group of people. They know certain things. That's the way it's been done for the last 50 years. I'm just trying to see who in the room is very old. And they do not want to change. They think their way is the best way, and they're not very keen in changing or adapting to new technologies. We also have the challenge with our people underground, our crews underground. They see technology as a if you bring a big new machine on, they see it as taking away from your jobs. You're going to take away their jobs. So we're sitting with those two different cultures. Makes uptake of new technology very, very difficult. We have a lot of data, and we've already had a few discussions with, or where people presented data and what you can do with data. However, if you look at the amount of data that the mines have, it's trillions and trillions of points. So to actually try to get the right data for the right purpose is quite time-consuming and expensive. A lot of techs are quite expensive. If somebody says to me, oh, why don't you send drones on the ground, and I want to run away, it's expensive. Imagine sending R1 million technology on the ground and getting it smashed up on the first day. Obviously, I spoke about the labor. We know there's a lot of challenges with standards, obviously regulations. You have to comply to certain, Reece spoke about gas explosions. There's methane. It's explosive. You can't just send any tech on the ground. Obviously, safety. We know we're going deeper. The deeper that you go, the higher the risk. We know shallow and narrow excavations, especially the area that we work in. We work in the platinum and gold sectors. It's hot and humid. Even though I'm quite hot here, I think it's been better to go underground. The areas are quite far, so you can't just send something down and expect it to come out in an hour. Some areas you have to travel for over 7 kilometers. And then obviously there is infrastructure, but most of it is old. So if you think you can put underground a 4G or 3G system, it will be very difficult. Communications is non-existent in most of the places away from the shore. So it sounds easy, but it's not. However, I think there's a lot of opportunities. I spoke about the mines being deep and narrow. However, I think there is sticks that we can reduce in size. Especially, I'll talk about the diamond drilling. We've identified there's some technologies that's been used for one thing, for instance, GPR or ERT. But we've actually been able to use it for underground purposes as well. So you don't have to reinvent the wheel, it's there. You just need to repurpose it. New technologies are sustainable. Obviously, we've been looking at technologies in other industries. I've mentioned AI and machine learning, but there is some opportunity for us to actually make mining a bit better and easier. The environmental side, I mean, obviously, I don't know if you guys have been watching the news in Europe. Everybody's striking the farmers because of the environmental. The farmers have to comply, and they get nailed, and they don't make money. But the mines are experiencing the same thing, especially in South Africa. So new technology can help with that. Obviously, cost, everybody's talking about cost, but I think if you can look at new technology, it can actually help with the cost and obviously improve productivity. I spoke about a bit about integration of different technologies and then obviously skills and people. And I'll take you through an example where we're actually using new technology to help develop skills. I mean, we can't expect our mine workers to stay laborers. You want them to grow as well. And then obviously, as I mean, the cost of technology will get better and cheaper. It has been. And then we're busy with what we call the industry test mine facility, and that mine will be made available to industry for testing. Rather than going to operational production mine, you can go to the test mine, test it there first. If it fails, you can retest rather than just going straight to the mine. I think that's most of me, hopefully with the typing. So the first one that I would like to show you guys is this module project that we've been busy with now for 5 years. It's been quite a pain. So in the first year we identified or tried to identify alternative ways to drill. So I'm not sure who's familiar with underground diamond drilling. So it would be just digital, I think it maybe two. So you would see a big rig on surface and you would think that's the standard we're using underground. It doesn't work like that. We have a limitation on our rigs. It's about a 2x3 meter size cubby that we need. So you can imagine it's a 2x3 size rig. So if you compare it to maybe a surface rig where it gets driven around by a truck, diamond drill rig is a lot smaller. But we're very dependent on these drilling activities to get information ahead of the mining operation. So it's not for exploration, it's more for structure, bramble gases, and sometimes grade. So we're looking at alternatives, and we actually realized that diamond drilling is probably the best option for underground drilling. Look at RC drilling or other methods would actually not work. But we realized as well there was a lack of skills within the field compared to overseas. So we've been looking at obviously ways and things people have been doing, and we know in the gas industry, gas and oil, even if you look at the exploration side and surface, they actually use sensors on their rigs. So the whole theory was, can we actually put some sensors on our rigs to actually get some more information while we're doing diamond drilling? So you can see on the bottom left, we've got our little rig there. Show, okay. So what we did is we initiated with a diamond driller, and obviously this work is being done within Victoria, Lesedi, and Sibanya. Tried to mimic a rig, and then we set it up with sensors, and we actually managed to drill through some pieces of samples. So this is where the engineering stuff comes in. Obviously, we tried to measure the torque, we measured the speed of rotation, all that type of stuff. And we actually realized that you can actually associate some of the properties or the information that we're obtaining from the rig. You can actually apply it to some geophysical or geotechnical properties. For instance, if the rotation is a certain speed, you can actually see, okay, this might be this rock. So what we currently did, or what hopefully one day the rig will go underground, we actually installed some of these sensors, and there's about 12 different sensors on a Lesedi rig. I just want to see if this video will play. And I'm going to forward a lot of the stuff on.
Okay, this is
how do I
a
change
quick
the speed?
tour of the adder drill that we have instrumented. Okay. So we use the power pack, and this.
So I just wanted to show people that you can actually, then it's to
our
need
EDAX
to
data
change
logger,
equipment. You can actually add stuff on and sensors
11
on,
channels,
get the relative information. And I can
we
see
can
this.
go up to 12 channels.
I just want to
The
forward it
setup
on.
it is totally
We've got a data logger that's
but
been
we are
installed,
going
so
to
it's
use
only
11
temporary.
channels.
We've added a little microphone to pick up sound while we're drilling.
Incidence microphone.
And then some pressure valves, a taptometer, all kinds of things, tilt meter. So while this rig will be drilling underground in the real environment, we'll be able to give us some parameters back. And hopefully from that we can establish a relationship
another pressure sensor
of,
over here.
The way it's penetrating the rock
drill.
and it's rotating.
So with that, we
can we actually say what type of rock it is?
measure
so this is quite cool.
the
This is
weight
very
on
interesting.
bit.
Obviously, hopefully it will help
So the force that
the operators
the drill
as
is
well.
being pushed
Now I need to
in
get back
into the rock. Over here is a tilt sensor. You can see in
so some more of the
sticking out.
sensors.
That's going to measure
I
the
guess this is
orientation
engineering
angle of the
stuff,
drill.
right?
Another pressure sensor over here.
Maybe just close the window.
to give us an indication of the clamping force.
Okay, then the next
on
one
the
that
drill
we've been
rods.
working on while trying to sort out the
Over here is
stuff is the thermal spooling project with VITS. One of the things that the guys and one of the other programs we're looking at is there a different way to break the rock rather than blasting the rock. So we know there's chemical, we know there's all kind of stuff, but this one where they were looking at thermal spooling. So what thermal spooling, I can see by everybody's look, they don't know what it is. You shock the rock, you actually apply heat, there's expansion, flaws, and there's some detachment. So it actually causes some flakes that come off. And this has actually been successfully applied at some gold mines. We actually tested it at Atona and Great Liqua, where they drilled holes and they actually put a flame in and it actually starts spooling the rock. And they've been doing it at some of the in some mines in Canada as well. So what we wanted to do is, would this technology work in a platinum environment? But we didn't want to test it underground first. We wanted to have some lab on surface to test it. So what we did is we designed some very basic sketch. We tried to get a frame to it, and obviously with some gadgets. And you can see at the bottom is how we put a rig together. At some time in the safety people told me, no, we need to secure it, and I had a bird cage to have this thing inside. But ultimately what happened was, this is actually one of the VITS samples that we actually sport sites that we actually send through this jig, and obviously it has to be controlled. And it just wants to show us this the whole time. And you can actually see there's some flaking. So if it's done in a massive state, you can actually mine it quite nicely. I think if you guys go outside here as on the grass, you'll see there's a spalled rock there as well. But when we try to do the platinum or the bushveld sample, something really weird happened. It did not flake. It actually started to melt. So that's how we actually managed to apply some of our geological, geotechnical properties, and and unfortunately we killed this project in the bushveld because we knew it wouldn't be able to get spalled. It would actually melt the rock. Okay, this is Musa's baby, and I think SRK and a lot of Geolink and a lot of guys that's in this room has been participating in the tunnel seismics. Originally we started at Masebe, the test mine, and then we moved over to South Deep. I'm not going to go into the technical things, but what I wanted to show is that sometimes when you put geophysics and engineering together, you can actually bring along a lot of students. And the exposure on this specific project that we had with all the PhDs, and I'm sure we missed quite a bit few, but there's a lot of MSCs and PhDs that participated. So just having a project like this, participating, working on the mine, gives the students opportunity and exposure, which they would have never been able to do. So maybe I can say, oh, that's maybe where geophysics and engineering. Good. So just some cool video of some of the stuff. I'm not allowed to say doof doof truck, but that's Mrs. Doof Doof truck, where they've been taking some want to get some data. I'm not going to say what they did exactly. I'm not allowed to. I'm joking. But just some of the underground. So one thing about this project, we were able to test on surface and underground and do some active and passive seismics. But one of the things that came out from all the work that Musa did was that they actually picked up some reflectives from a train that passed. So from the original planning that we had, to get from the doof doof machine and everything else, this is one of the cool stuff that we picked up, was these reflectives with a vehicle or a big truck passing. And I think that's one of the cool things, is when you're doing the research, especially in geophysics, and you start looking at other things, you might get a bonus like this. Okay, some of the other stuff that we've been working on is GPR. So I usually tell people that if they don't know anything about geophysics, geology, or anything else, that you use GPR to get dead bodies on the surface, or some money or something. It's that stuff that moves underground. Obviously, we know GPR works underground. I think we've got Rutech that's already got a commercial product available. But what we wanted to do is obviously try to see, is there anything else that we can do with GPR rather than just get the structures or the fractures there above in your hand. So we've got 3 use cases here. The first one that was a boo-boo was the one at South Deep, where we wanted to actually see the extent of the lavas. But what the guys didn't tell us is that they actually have the whole area supported with steel mesh. GPR doesn't work with steel salaka. So it's a finding. We can deal with that. Another one that we wanted to try was the second one at Sapong, where they had a clay type of rock type just above in the quartzites. So they had the hang and then a small sliver of this funny clay material, and then again, and there was arguments about what type of material it is. It's just a weak zone. And with the scans, we were able to pick it up. So it can actually pick up different pathologies. And the third one is at the test mine. Is where we've got in the footwall, they've got declines, and at some point in time, you pick up the reef, but the reef is running below these declines. And what we did is we ran the GPR, and the GPR was actually able to pick up the reef below the tunnels. So not only can you use GPR in the hang and to find dead people on the surface or whatever, but you can actually use it for other methods as well. So another use case that we had, or that we've been tested, and I've spoken to one of the guys from Open Surf, Open House, sorry. The Open Ground is the ERT. Ground house. And when I try to explain this to people, obviously we know it's been used quite a lot in sensors, in soil, the soil environment and surface, trying to find water, different clays. It's been used in the medical field. In the past, I think about probably 10, 12 years ago, they tried ERT underground and it took way too long. So what we did is there were some updates with the Super Stinger. We used some new modes or couplings for the sensors, electrodes, as well as some other modifications. And we did a test, actually 2 tests, one at Maseve and one at Impala, where we actually managed to improve the time. It used to take 2 days. We actually upped the time by 1 day only. So it takes you a shift to actually go and do an ERT survey. Unfortunately, the mines weren't too excited about this one. I think we all know it's quite tedious to do an ERT survey, and especially if you tell them you're going to shock the rocks. But I think you can see some of the results down there. We managed to pick up the dike. We actually managed to pick up some structure. So it is a technology that you can look into. Somebody spoke about the thermography or the TSP or the dumps on surface. We've looked at thermography for underground, where the theory is if you can actually see loose rocks, there should be a difference in temperatures between the rocks that's solid and the ones that's loose. We've done quite a lot of testing, and most of the results has not been good. But we're hoping we can get some better results. Yeah. So I'm going to take you guys through some of the current stuff. So we're working currently with what we call the ITAD. It's a prototype, and the whole idea of the ITAD is to actually look at acoustics and thermography in one device. So the idea is to actually see, can we actually, whenever he goes into area 2 before the mine will blast, the miner has to make sure that area is safe. And what they do is they actually use a pinch bar, a piece of steel, and actually whack the hang. It sounds weird. But that's actually what they do. When the miner taps this hang, from the sun it makes, you can actually say if this rock is solid. So we know our miners, some of them are old, some of them are not always the sharpest, So sometimes they actually miss these loose rocks. So what we're trying to do is there some equipment or some device that we can use? So when they're tapping, the device can tell them or confirm with them this and this thing is loose or solid. So I'm just, this is now a prototype, but again, where the engineering stuff comes in, RTAT version 1, the thing on the guy's head, and version 2 was different shape. And currently, I think we're actually now in version 4. This is the same as version 3, where they've got everything in one device, and you can actually see everything on the screen. So this is where the cool stuff comes in. So this is the thermography. Where you can see Sipu standing there against this loose piece of rock. You can't see the loose rock, you can see Sipu. But the cool thing is on one screen, and I promise you there's a loose piece top there. Okay, this is where we test the eye test. So there the miner is whacking the sidewall. In this case, we were trying to test if all 3 devices would pick it up. 3 devices said this is loose, red. And then the next example is just where he's whacking the rock, and this piece of rock is solid, and all of them said it's solid. So we are doing quite a lot of testing still with this device. We're done with the platinum sector with some mixed results. The main thing is we've got consensus between the different devices of 90%. So that's one good thing. Obviously, the code that's inside it was set up for a specific operation. So 48% is bad, but it's actually not that bad. But then we did some analysis on specific skill sets and rock types and all that stuff. So this is, yeah. So then, one of the cool things that we're busy with is LiDAR. And I think everybody can agree that it's probably one of the best ways to replace some of the stuff that us as geologists, rock engineers, safety, whatever is doing. It gives you a nice true picture of what's going on underground. However, I think we know getting these scans with a tripod is quite expensive. It's fair enough to send this equipment, but then you still need a specialized person to go underground, which we might not be able to afford. You need it to be usable by all mining crews. So we accidentally came across one thing, and you've seen Caller taking pictures at the back. The iPhone, it's things that is available. The tech is there. It's open source and all that lucky stuff. Went to one of our mines last year, K4, and this is Alex doing a scan in one of the development tunnels. So you can see he literally just goes around in circles. And this also, I thought this video was quite cool to show you guys as well how underground actually looks like, for those that don't know. Okay, and then the next one is in the stope. So this is actually a very nice stope, even though some people might not think. So we're expecting people to actually work in this environment and try to get information. But these guys, we had Stratify walkers in after me, but we actually had a scan done of this panel. Yeah, but I think it's quite realistic. Didn't put the sun on it, else we just hear people groaning. So just some, and this is again something that is available. It's openware, software, and that's the stuff that they crawled into. Actually, with the scan that they did, this is actually the type of quality that they managed to get. So I mean, there's no need to really reinvent this wheel, unless you've got iPhone and say you're not allowed to do it anymore. And like I said, Neil and them's got some other cool solutions as well with their photogrammetry. And then this is just some of the stuff, development tunnel that we picked up. So this is, I actually plotted this stuff, so it's very easy. If I can do it, everybody else can do it.
Second one is also from the iPhone.
Oh, both, everything.
What software is it?
It's Cloud Compare. Okay, so just in conclusion, geophysics and engineering, I think you guys have got the two together comes up with quite cool solutions. And thank you very much. And I'd like to thank you very much.